Like, hi, my fellow friends. Today is about taking a journey. Come with me as we journey where? Through the solar system. Are you ready? Let's go. The solar system. Our solar system has a single sun. We talked about the sun being a ball, a swirling, rolling wall of fiery gases and explosions and flares that can be seen way throughout our solar system. We see the sun very brightly, and it relates directly to our life on planet Earth. Our sun is not as close to Earth as we would think. Our sun is 93 million miles away, but we depend on it for life itself. Some planets are further away from the sun, so they're very, very cold, and they have no air, and there's no life. So when we think about the energy that keeps going, that keeps us thriving, we can't ignore the sun. The first planet from near to far is Mercury. Mercury is a very small planet, but it's very hot because it's close to the sun. Mercury has no moon, it has no air. Then we have Venus. It's very close in size to the Earth. It's very, very hot, and it has an atmosphere that's actually made of carbon dioxide, not oxygen. So you can't live there. You need oxygen. Venus, full of carbon dioxide. 3, the Goldilocks planet, Earth. Not too hot, not too cold, not too close to the sun, not too far away from the sun. Earth is what you call the just right planet. Just right to sustain life. That's why it is believed that there's life in no other part of our solar system but on Earth, because a little too hot makes it inhospitable to life. A little too cold makes it inhospitable to life. Earth is just right. Then we have Mars. Mars is, in terms of being able to live on any of the planets, if we were to venture and say there's a planet that we can possibly live on, it would be Mars. As a matter of fact, right now as we speak, there are 2 robots probing Mars, and we are truly looking at the science that would be necessary to create a colony on Mars that would support human life. Pay close attention to what's going on in science, because before you know it, we may be living on Mars. Next in line, away from the sun towards the outer limits of the universe, is Jupiter. Jupiter is a giant gas planet with 67 moons. We have 1, but Jupiter has 67. So I think Jupiter won bingo on Moon Day. When you look at Jupiter through a telescope, you see kind of like a big red blotch on Jupiter. That blotch is actually a storm that's been raging for 200 years. How would you like living through a storm that's lasted for 200 years? Just be thankful that we live on the Goldilocks planet. Next, Saturn. Saturn is known for its rings. Many, 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 many rings that look so beautiful through a telescope. But those rings are actually dust, rocks, and ice. So I guess if we're really close up, it looks like poor housekeeping is surrounding Saturn. But those rings at a distance look quite beautiful. But remember, Saturn's rings, dust, rock, and ice. Next, Uranus. Oh, a giant gas planet that does something that no other planet does, my friends. When Uranus, when it rotates, it doesn't rotate this way. It rotates this way, like a bicycle wheel. Just imagine what life on Earth would look like if instead of spinning and rotating this way, we were like a bicycle wheel. Just use your imagination. You know what? You may even want to try to write a story about living life on a planet that rotates like a bicycle wheel. I'd love to read that story. The next planet, Neptune. Neptune has the longest orbit in the solar system, 164 years to make its way around the sun. It's a long way from the sun. It's huge. There's no life on that planet, no life that we know of on that planet. It takes us 365 days, 12 months to go around the sun. Well, imagine 164 years. I'll let you run with that. Last but not least, Pluto. We're gonna put Pluto in parentheses because Pluto's not really a planet. It's much smaller. We don't really talk about Pluto anymore as a planet in of itself. It's more like a dwarf planet, like a planet, get it? So when you think of the planets in our solar system, you can think 8, and then just so that we don't hurt Pluto's feelings, we'll say, you can come along for the ride, but we know you're not really a planet. Come back next time for Science Talk. Love spending science time with you. Be good. Bye. You can think 8, and then just so that we don't hurt Pluto's feelings, we'll say, you can come along for the ride, but we know you're not really a planet. Come back next time for Science Talk. Love spending science time with you. Be good.
The sun is in the center of our solar system. Tap on the sun. Jupiter is a giant planet with lots of moons. Tap on Jupiter. Venus is a planet that is about the same size as Earth. Tap on Venus. Uranus is a planet that spins on its side. Tap on Uranus. Saturn is a planet with beautiful rings that are made out of dust, rock, and ice. Tap on Saturn.
Today we are going to be learning about the planets. There are 8 planets that go around the sun. Their names are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Let's look at some pictures of these planets. This is a picture of Mercury. Mercury is the smallest planet of these 8 planets. This is a picture of Venus. Venus is about the same size as Earth. Sometimes we can see Venus from Earth, but if we are not looking at it through a telescope, it will only look like a very bright star. This is a picture of Earth. Earth is the planet that we live on. On Earth, the white that you see on this planet is the clouds. The blue that you see is the water, and the brown and green is the land. This is a picture of the planet called Mars. Now, Mars is just a little bit smaller than Earth. Mars has 2 moons. Earth only has 1, but Mars has 2. Some planets have a lot more moons than just one, but Mars only has two. This is a picture of Jupiter. Jupiter is the biggest planet of all of these planets. On Jupiter, it has this spot. The spot is a huge storm that is going on the planet. Jupiter also has many moons. It has 63 that we've discovered, but there are probably even more. This is a picture of Saturn. Saturn is the second largest planet. It is smaller than Jupiter, but bigger than all of the others. Saturn also has lots of moons. Now, Saturn has these rings that go around the planet. These rings are made from dust, rock, and ice. This is a picture of Uranus. Uranus is smaller than Jupiter and Saturn, but it is also bigger than all of the others. Something very interesting about Uranus is that instead of spinning the normal way that most planets do, it spins on its side. This is a picture of Neptune. Neptune is just a little bit smaller than Uranus. So it is the fourth largest planet because it is smaller than Jupiter, Saturn, and Uranus. Neptune has a spot kind of like Jupiter. Neptune's spot is also a storm. So today we learned about the 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Today, I'm going to teach you a sentence that has 8 words. Each of these words will start with the same letter as the planets. So the first word will have to start with an M for Mercury. So I'll tell you the sentence, and then this will help us remember the planets and the order that they are in. My for Mercury, very for Venus, educated for Earth, mother for Mars, just for Jupiter, served for Saturn, us for Uranus, and noodles for Neptune. So the sentence is, my very educated mother just served us noodles. This will help you remember the 8 planets. Let's review what we've learned. We learned that all 8 of the planets go around the sun. We learned that the biggest planet is Jupiter, and that the smallest planet is Mercury. We also learned that some planets have a lot of moons that go around that planet. Now let's do a problem like the one that you are going to do. Jupiter is the biggest planet. True or false? So you remember that Jupiter is the biggest planet, and so you click true. Have fun.
Uranus is smaller than Jupiter. Find Uranus. Mars is smaller than Earth. Earth is the planet we live on. Find Mercury is the smallest planet. Venus is about the same size as Earth. Find Venus.
Hello, my Acellus partners in crime. We have a trip to take today. You'll never guess where we're going. You can never guess where we're going. I'll give you a hint. 5, 4, 3, 2. Wait. Let's strap ourselves in. Got your straps on? 1. Blast off! Yes, folks, we're going to space. Why would we go to Hello, my Acellus partners in crime. We have a trip to take today. You'll never guess where we're going. You can never guess where we're going. I'll give you a hint. 5, 4,
Rosa!
3, 2. Wait. Let's strap ourselves in.
1.
Got your straps on? 1. Blast off! Yes, folks, we're going to space. Why would we go to space? And who does that kind of stuff? Well, I'm about to tell you. People who go out to outer space, scientists who go to outer space, are called astronauts. Why do they go? Well, because the space is a very different environment than our environment. In space, the sun shines all the time. In space, there's no air. And in space, you float around because there's so little gravity. It's true. You float around, there's no air, and the sun shines all the time. Very different environment. So astronauts are scientists who study what space is all about. Some astronauts get to fly the vehicle that takes them to space. It's called a space shuttle. And pilots of the space shuttle have a very different kind of training than the astronauts or the space scientists who are going to go and do research. So you'll always have a scientist who's piloting the space shuttle, and you'll always have a group of scientists that are there to do research and conduct experiments in space. Now, the space shuttle, which is the vehicle that takes scientists, astronauts to outer space, it takes off like a rocket, but it lands like a plane. Very unique vehicle. Inside, it looks like a laboratory and a toolbox all rolled into one, because everything they're going to need to survive and do their experiments, do their jobs, has to be in that space shuttle. So, another consideration, we said there's no air and things float. They even have to strap themselves into sleeping bags just to sleep. You see, they have to go through a very rigorous training program to get used to all the differences they're going to face when they're in space. So astronauts, scientists who study in outer space, have to go through a lot of preparation just to understand the effects of that very unique environment on their bodies. They also have special equipment so that they can exercise there. They have to keep their muscles strong in space, so they have to exercise regularly, because without gravity, their bodies can become very, very weak. So these are very brave men and women who go to outer space to bring us back some wonderful technology and ideas to make life here on Earth easier, but also to explore the opportunities that may lie in life in outer space. Thanks, my Acellus partners. Can't wait to see you next time.
Astronauts exercise in space. Tap on the astronaut that is exercising. Inside of a space shuttle, there are many tools and controls. Tap on the picture of the inside of a space shuttle. Some astronauts are pilots. Tap on the astronaut that is a pilot to a space shuttle. Some astronauts do research in space. Tap on the astronaut that is gathering moon rocks. A space shuttle takes off like a rocket. Tap on the space shuttle that is taking off. Find the picture that was taken during the day. Find the moon that goes around the Earth. Find something that can often be seen at night and sometimes be seen during the day. Find something. We live on planet Earth. Find the picture of Earth. Find the person who is wearing a spacesuit. Mercury is a small planet that is the closest to the sun. Tap on Mercury. The sun is in the center of our solar system. Tap on the sun. Uranus is smaller than Jupiter. Find. Mars is smaller than Earth. Find. Inside of a space shuttle, there are many tools and controls. Tap on the picture of the inside of a space shuttle. Some astronauts are pilots. Tap on the astronaut that is a. Find the child who is outside during the day. Tap on the picture of the night sky. Tap on the moon that takes 28 days to go around the Earth. What can we see moving across the sky during the day? Find the picture of the sky at night. The moon is smaller than the Earth. Find the moon. Pluto is too small to be called a planet, so we call it a dwarf planet. Tap on Pluto. Humans have sent robots to the planet Mars. Tap on Mars. The planets orbit around the sun. Find the sun. Find the planet. Some astronauts do research in space. Tap a space.
Hi, my Marcella's friends. I'm glad you made it today. I've been waiting on pins and needles just to see you. Why? Because when we get together, we have a special science talk time where we get to stretch our minds and imaginations and take in all that science has to offer. So let's not waste any more time. Let's get started. Today's topic, let's learn about matter. Okay? You ready? From left to right, I want you to look around wherever it is you are. Scan everything from up to down, from left to right, top to bottom. Let's begin. Kind of amazing all the things you can take in. When you're just quiet and you're looking around, you really become conscious of all the things that are around you. Now let's go back around from the left to the right. You may even notice things that you didn't notice in the environment before. But everything that you just saw, everything that you can touch, everything that you can smell, lift, is matter. Matter is everything that has mass and volume. What is mass? Mass is the amount of stuff in a thing. So not everything has the same amount of stuff inside. Let's take this pen. The mass of this pen is everything that's in this pen. Let's take this table. Mass of this table is everything that's in this table. So everything has mass, but as you can see, my pen will not have as much mass as this table. Now, volume is a little different. Volume is the amount of space something takes up. So if we compare the volume again of my pen to the volume of our handy dandy table, of course the pen has less volume because it takes up less space than the table. But everything has mass to differing degrees. Matter is all the stuff, the little particle stuff in our world, in our universe, in everything. Air is a kind of matter, even though we cannot see it. Air has mass and volume, because even though we cannot see air, there are tiny particles in the air that give air mass. And air takes up space, which gives it volume. Matter can be a solid, a liquid, or a gas. You guys are the best. See ya next time.
Which plate has less mass? Find the ball with less volume. Tap on the shell with more volume. Tap on the box with less volume. Find the object with less mass.
Today we are going to be learning about solids, liquids, and gases. I brought all these things today, and David will tell me if it is a solid, a liquid, or a gas. Now, David, a solid is something that keeps its shape. A liquid is something that, depending on the container it is put into, it will change its shape to take up the space in the container. And the gas can change its size and shape depending on the container that it is in. Air is a gas. It takes up space, and air is matter. So let's look at these things, and David will tell us if it is a liquid, a solid, or a gas. David, is this a liquid, a solid, or a gas?
A liquid.
Yes, inside of this container, it is a liquid, but the container that it is in is a
Solid.
A liquid will take the shape of its container. Now let's look at this. This is a tower of cubes. Is it a solid, liquid, or a gas?
Solid.
Yes, it is a solid because it does not change shape depending on its container. What about this?
Liquid.
Inside of this cup, there is a liquid. Now this ball is a solid, but inside of the ball, what does it have?
Air.
And we learned that air is a type of
Gas.
Yes, air is a type of gas. So inside this ball, it is full of gas. What about this watch? Is this watch a solid, a liquid, or a gas?
Solid.
Yes, because if we put this watch into a container, it would keep the same shape. What about this? Inside of this container, is it a liquid, a solid, or a gas?
Liquid.
Yes, there's a liquid in this container. Even though there's gas in the other part of the container taking up the space, inside of this container, it is mainly a liquid. Now what is this? Is this a liquid, a solid, or a gas?
Solid.
Yes, it does not change its shape. What about this rubber ducky? Inside of this rubber ducky, what is inside of it?
Air.
And we learned that air is a
Gas.
So inside of this rubber ducky, there is gas. Now let's look at this balloon. Now when there's nothing in it, it is a
Solid.
Yes, it is a solid. But when I fill it up with air, when I fill it up with air like this, what is inside of it now?
Gas.
Yes, now it is full of gas. And if I tie it, it will keep the gas inside of the balloon. Now let's look at these glasses. Are these glasses a solid, a liquid, or a gas?
Solid.
Yes, these glasses are a solid because they are not changing their shape. Now let's get these out. Now these are bubbles. Now bubbles, when we look at them in the container, they're a liquid, aren't they? But if I get them on this plastic piece and I blow, and I make a bubble like this one, as soon as it falls and pops, it will turn into a liquid. But inside of the bubble, what was inside of it?
Air.
Yes, so the bubble also has gas inside of it. Even though the outside is a liquid, inside of the bubble, it has a gas. Let's review what we learned. Today we learned about solids, liquids, and gases. All of these things are matter. Now, a solid will hold its shape. No matter what container I put this solid in, it will keep its shape. There are liquids, and they will change their shape depending on the container that they are put in. And there is gas. Now, gas we usually cannot see. But when we put it into something like this balloon, it is taking up space. And so then we can see the space that the gas is taking up. The gas can change its size and shape depending on the container that it is put into. Now let's do a problem like the one that you are going to do. Find the thing that is filled with gas. So you remember that rubber duckies are filled with gas. And so you click on the picture of the rubber ducky and you move on. Good luck. Where is the solid? Find the solid. Find the thing that is filled with gas. Which thing is filled with gas? Find the solid.
Welcome all of my Acellus viewers. It's Ms. Hellman. Today we're going to talk all about what are gases. And are all gases the same? Have you ever thought about it? Take a big deep breath. Hold it. Now let it out. And you know me, roll those shoulders back twice. Boys and girls, with the gases that you just took into your body, are they all the same? You know, and I know that in the air that we breathe, we can't even see the air, but we know it's there. When you breathe in, your body took in oxygen, and when you breathe out, it gave back out into the air CO2, carbon dioxide. But are they all the same? The answer today is no. Boys and girls, I want you to take a look at this jar here. Now, this little old mason jar is from over 100 years ago. Inside of this jar, do you see anything? But is something there? Yes, gases. You are so correct. The same air that we breathed in, that's matter inside of there, even though we can't see it. Now, let me talk about gases in our world today. Let's name a few. Well, we talked about oxygen already. We talked about CO2, carbon dioxides, and then we have gases. What about the gas that is at your home? Maybe the gas that is used so you can turn on your oven? What about the gas if you're at a dentist's office and they put a little mask over your nose and then all of a sudden the pain, it doesn't hurt anymore at the dentist? Because we all visit the dentist every year, don't we? Maybe a couple times. But that very gas is much different than the gas maybe that we breathe like oxygen. There are differences. Some gases, I'm gonna put my goggles on for this one. And also, because I have long hair, in the lab, we always tie back our hair. Some gases, are you ready? Burn. What's causing this lighter to burn? Well, there is a flammable gas inside of this gun. And when I take the safety off and it ignites right now, it's burning not only the gas here, but it's staying aflame because it is burning oxygen, just like a candle. Boys and girls, what makes a gas? Well, I'll tell you what, gases are molecules. On my shirt here, we have something called the periodic table of elements. Well, some of those elements are gases. And some of those gas, boys and girls, what makes a gas? Well, I'll tell you what, gases are molecules. On my shirt here, we have something called the periodic table of elements. Well, some of those elements are gases. And some of those gases are gases because their molecules are moving so quickly. There's so much energy, and it's called the periodic table. Of elements. Well, some of those elements are gases. And some of those gases are gases because their molecules are moving so quickly. There's so much energy and so much space between, so much energy, and they are moving. That's what makes a gas. Some gases we breathe, some gases we can burn, some gases we can contain. Oh. Because some gases we can trap inside of one of our favorite things, a balloon. Birthdays have balloons, celebrations have balloons. Well, today our science lab, What Are Gases, is going to have a balloon. And we're going to talk about that sometimes gases can be heavier or more dense than other gases. Here we go. Let me blow this one up and let's see. That sometimes gases can be heavier or more dense than other gases. Here we go. Let me blow this one up. Let's see. That's right. I'm taking all the air out of my lungs and I'm pushing it in here. Good thing I went for a run this morning. I'm gonna go ahead and tie this off. Now, this balloon here has the gas in it that I exhaled from my lungs. But look at these guys. Something very special happening with these. Besides the fact that they're shiny and really awesome looking, there's a difference with the gases that I trapped inside of this balloon and the gases that are in that balloon. Let me see if you can figure it out. Watch the behavior of the gases. Okay. Are you ready? On the count of 3, I'm going to let go of both balloons. Are you ready? 1, 2, 3. What happened here? Did you see it? Point to the balloon that you think has gas inside of it that is heavier. Is it the silver balloon or is it the pink balloon? You're pointing at the pink balloon. The gases inside of this balloon have more density than the air that we're breathing here. But what about these guys? What about these guys? What's happening to them? Ready? As a scientist, I would say the air inside of this balloon, the gas inside of this balloon is actually lighter than the air that we are breathing. Isn't that fantastic? That means that helium, yes, the gas that I had the lady at the store.
Helium. Gas. Helium.
Push in from her cylinder. She hooked up that balloon and she went and filled up these Mylar balloons that are now floating. Well, what's causing them to float is the helium, the gas that's inside of these balloons, is lighter or less dense than the air. Boys and girls, there are so many cool things to learn about the gases in our world, the gases here on planet Earth, and even the gases that make up our stars. Yes, by the way, hydrogen and helium make up our very own sun. Amazing what we can learn about gases. One of my favorite types of science labs having to do with gases have to do with what's inside of here. So ladies and gentlemen, without further ado, gases rock. Until next time. Awesome.
Find someone breathing oxygen. Tap on the person who is breathing gases on the candles. Tap on the thing that is filled with gases. Find a gas that is being burned. Tap on someone who is blowing invisible gases to make something.
Today we are going to be learning about mixing solids and liquids. Today I've brought this soup. This soup has both solids and liquids, but they are mixed together to make the soup. We can separate the solids out. We drain the liquid off. You can see that I just have solids. And if I want to, I can get a spoonful of just liquid. So we can separate the solids from the liquids if we want to. Now, here I have a spoon, a beaker, and some beans. Now, what we are going to do is we are going to try dissolving these beans into this water. Now, dissolve means to spread something throughout a liquid. Now let's add these beans to the water. But before we do this, David, are these beans a solid, a liquid, or a gas?
Solid.
Yes, they are solid. So we'll put these solids into this liquid. Make sure we get all of them in there, and we'll stir it up and see if the beans dissolve. Now let's take out the spoon and we'll see if the beans have dissolved. David, are the beans spread all throughout the liquid?
No.
You see, the beans have all settled to the bottom. They're not through all of the liquid, but they're only at the bottom. This means that they did not dissolve. Now we are going to do another experiment with dissolving. We still have the spoon and the beaker full of water, but instead of beans, this time we are going to use salt, and we have something to measure it. Now we will take the salt and we will put it into the water. I do 2 whole things full of salt. That's a lot of salt. Now we'll stir it in. You can see that the salt made the water more cloudy. Now let's look at this and see if it's dissolved. David, do you see all the salt at the bottom of the beaker?
No.
The salt has dissolved into the water. Some solids, like the salt, can dissolve into the water. Remember, dissolve means that it is spread throughout the liquid. And that is what the salt has done. Now that we've added the salt to the water, this makes it into salt water. If we tasted the salt water, it would taste salty. Even if we tasted the bottom or the top, it would still taste salty. That means that the salt is all throughout this water. Even if we look up, Through the water from the bottom, we can still see that there is no salt collected at the bottom. So this salt has dissolved into the water. Now let's review what we've learned. Today we learned that solids and liquids can be mixed like in a soup, and we can separate the solids and the liquids. We learned that some solids, like the beans, would not dissolve in this liquid. But when we tried the salt, which is also a solid, it dissolved. Not all solids dissolve. Some do, and some don't. Now let's do a problem like the one that you are going to do. Salt can be dissolved in water. True or false? So you remember that salt can be dissolved in water, and so you click true. Have fun.
Which picture shows salt dissolved in water? Find the mixture with solids in a liquid. Tap on the mixture of solids and a liquid. Tap on the mixture of solids in a... Which picture shows a liquid being mixed with a solid?
Today we are going to be learning about how water can change. Water has 3 states. Its 3 states are solid, liquid, and gas. That means that water can be all 3 of these things. So let's see if we can change it from a solid all the way into a gas. Now right here, I have this ice cube. You've probably seen an ice cube before. This is made by putting water into a very, very cold place, and then it will turn into a solid. We can put water into a freezer, and then it will turn into ice. Now here I have brought a beaker of snow. Now here where David and I live, we got a snowfall. So we had some snowy weather. Remember that snowy weather is a kind of wet weather. Snow is made from frozen water. So is this ice cube. Although they look different, they're water in the same state. So now let's put this snow and this ice cube that are both in their solid state onto this hot plate, which will melt them into a liquid. Now we are going to need to wait until the ice cube and the snow have melted. Now it's been a few minutes, and because of how small the pieces of snow were, it's melting really fast. You can see that there's still some solid, but most of it has turned into a liquid. So you can see that as water in its solid state is warmed up, it will turn into water in its liquid state. Now this water that was in its liquid state has gotten so hot that it is bringing up bubbles from the bottom. This is called boiling. If we look closely, we can see the gas coming up from the top. It is turning into gas. It is going into the air, and we can't even see it. It is turning into water vapor. If I hold my hand above it for a minute, and then I fill my hand, it feels wet. I can feel the water vapor go to my hand as it comes out of the beaker. Now, as the water changes from a liquid into a gas, this is called evaporation. Have you ever wondered why the puddles go away? When it rains, we get all these puddles, but then after a while, they dry out and go away. Now, what the puddles do is they go into the air. They become water vapor. So those puddles will go away because they're going into the air. That is basically what this is doing. When it is hot, it goes faster. If I had a cup of water and I marked how full it was of water, and then I just left it out for a few days, when I come back, some of that water will be gone. It will have evaporated into the air as water vapor. So now let's come back over here and see how much of this liquid has evaporated into a gas. We saw that it was just above 100 milliliters. Now, look how far below it is. Now, if we look up here at the top of the beaker, we can see all these small water droplets. This is from the water vapor as it was coming up from the liquid. It hit against the side of the beaker, which was cold, and it turned back into a liquid. This is what happens when water vapor is cooled. It turns into a liquid. And then if we took this water that is still here and we put it into a freezer, it could turn back into ice. And remember, ice is the solid state of water. Now, if I take this black paper and hold it behind the beaker, then you will be able to see the water as it is turning into the gas state, also called water vapor. So this water is evaporating into the air. That is why this water level is getting lower and lower. So now, look at how low it is. It's like 50 milliliters. That's about half of what it used to be. That much of the water has gone into the air. If we keep boiling this water, soon all of the water that is in this beaker will go into the air. It will all be water vapor. As water changed from its solid state into its liquid state, and then now it is turning into its gas state. Now let's do a problem like the one that you are going to do. Find the picture of water that is evaporating. And so you remember that when water is evaporating, that means that it is changing from a liquid into a gas. And so you click on the picture of the water changing from a liquid to a gas, and you move on. Have fun. What does water look like after it has changed from a solid to a liquid? Where's the water that is becoming water vapor? Where's the water that is becoming water vapor?
đấy. Ngồi xuống.
Học rất là nhiều.
Mai bắt đầu học con
Con
đôi bán
làm đề thi tự chọn.
cái này học con đôi bán cái chứ.
Con làm đề thi tự lựa chọn.
Bạn là cái ta không bán này. Có gì con trai của ai này? Bao giờ định có đúng không?
Dạ, có nhưng ít.
Vì cái ta hứ. Như ba là này. Này. Chúng ta học rồi. Ngày mai ba giờ cũng ru con để có phải thi cô dạy chứ.
Dạ.
Hóa tốt. Trường con lắm.
Ba ơi, ba quay về.
Ba được cách má.
Ba ơi,
Ba được cách vắng rồi thấy được.
ta nhìn nước mà con là nước gì?
Nước nào?
Nước là con
Ghê.
đá. Nước đá. Vì nó không phải là nước này.
Thì như tạp chất nè.
Còn đây vì sao nước này mới là nước ngon.
Nước tinh khiết.
Còn vì sao không đá được?
Dở. Ngồi đi. Ngày mai bắt đầu học ai lên cái học ăn nuôi ba cái chứ?
Dạ con. Ok con gì?
Which picture shows water that has been frozen into its solid state? Where is the water that is evaporating? Where is the water that is turning into its gas state? What activity could you do on a rainy day? Where is the solid? What activity could you do on a rainy day? Where is the gas? Where is the liquid? Find the desert habitat. Where is the liquid? Click on the stem picture. What does a dog need? Click on the leaf picture. What activity could you do on a windy day? What activity could you do on a windy day? Where is the cliff? Click on the stem picture. Find the spring day. Where is the lake? Find the winter day. Click on the leaf picture. Find the summer day. Where is the liquid? Where is the liquid? Click on the stem picture.
Hello, junior scientists. You're back for some more science talk. That's what I love about you. What I love about you is that you love science just like me. We have so much in common. We have synergy. Today, we are going to talk about how matter can be changed. A straw, yes, a regular straw like the one you drink out of, can be bent and then it can be straightened. This is matter being changed, and then that same matter being changed back to the way it was at the beginning. When a popsicle melts, it turns into a liquid. This is matter being changed. Can this liquid ever become a popsicle again? It sure can. This liquid can be changed back into a popsicle by simply freezing it. We can change apples by cutting them into pieces. Once an apple is cut, can it be whole again? No.
Lên bằng đi Scratch. Thư lên lập thư lên bằng đồ thang lập trình lập trình bằng C cộng tổng. Lê cold không thể cold được, không học hướng dẫn cold
I'm going to pause the video if you would like to check out exactly what's going on. The board here is a little smaller than standard. Squares are 1.5 inch on each side. The original board has 2-inch squares, which makes the pieces more spread out. But with this special demonstration board, you're able to see the whole board in the screen and still see pretty well the individual image of each piece. Also, I've put letters to help to identify them. First, artillery moves forward here, which gives defense against these points out in the sea. The naval vessel
label.
moves up, not quite to those points defended by the artillery. This naval vessel moves up this far, confronting this one, but it's defended by this. Another naval vessel comes out, linking up. Air Force moves to 7-5. Boom, right there. I put some pressure on this one, but if this captures that, they both will be annihilated. 1-4, 2-5, 8, diagonally out here, trying to encroach on the enemy's territory. Captures N3-1. So he goes ahead and gets that, but they're both annihilated. The naval vessel moves from 5-1 to 2-1. So coming back down here, since this is the only remaining sea vessel, it has to defend itself, because if it gets captured, then blue will have won the war at sea, because there will be no remaining sea vessels. This one begins to encroach. This one moves over. This one comes in. Ganging up against this vessel. Back one to get out of range. But the attack is on. This one moves over. This one's now attacking that one. Once again, encroaching. The artillery is trying to drive the naval vessels away, but the naval vessel comes in here. Once this one is trapped, it's essentially checkmated. The sea battle is checkmated.
Checkmate. Combine.
Blue gets him in the final count. So we're going to count these two sea vessels. Each one's worth 80, so 160 points. Also gets 100 points for having victory in the game. And the red forces get credit for capturing one airplane, 40 points. Final comment here by the colonel. By the braveness of the blue force commit suicide their life that make advantage for the blue naval vessel in attacking the opponents. So this one sacrificed itself and won the sea battle. This game is sudden attack, and as you can imagine, it goes rather quickly. Air Force comes in, right in the center position. Engineer comes forward, beginning to guard the front line. This aircraft comes over here. Looks like Red is seriously considering an aerial assault. Blue's got the idea of his own. Air Force is coming forward, and
What will the interface?
this game is sudden attack, and as you can imagine, it goes rather quickly. Air Force comes in, right in the center position.
Yes.
It goes rather quickly. Air Force comes in, right in the center position. Engineer comes forward, beginning to guard the front line. This aircraft
And Air Force weak position.
comes over here. Looks like Red is seriously considering an aerial assault. Blue's got the idea of his own. Air Force is coming forward, and
A center game.
this Air Force comes right in the center. And
It will never be a whole apple again. After an apple is cut, it will begin to turn brown. When an apple turns brown, can it turn white again? No, the apple will not turn white again. Let's think about cookie dough. Cookie dough is matter. Believe me, cookie dough is not just matter, cookie dough matters. Well, anyway, when cookie dough is cooked, it changes from a sticky dough to a nice, firm, delicious cookie. Now, if that cookie is cooked too long, it can burn and become black. Once the cookie dough is blackened or burned, can it be turned back into a nice cookie? No. Again, These are more examples of how matter can be changed, but not always changed back to how it was at the beginning.
The aircraft gun moves. Forward, preparing perhaps to attack the Air Force. Red attacks the missile. Of course, the missile creates a defense against air attack. So this one gets shot down even while destroying the missile. It is said that the Air Force bravely sacrifices himself. Artillery comes in. The other aircraft comes over and hits this infantryman.
Check.
Here, he puts the commander in check. So doing, he becomes a heroic piece, able to go one step further than his original move. The commander, of course, moves out of check.
Nhanh được.
But the assault continues, flying. Straight down to the corner of the board. The commander is in check once again. The commander ducks into the headquarters. By stacking on top here. That's his prerogative as the commander. However, not safe enough. Air Force flies right here. Air Force is allowed to go diagonally, and so it's attacking the commander. Commander's escape points are also covered by the Air Force. So right away, the commander is checkmated. Red wins. How to play commander chess. I'm not going to try to pronounce the Vietnamese right now. I'm not quite there yet, but I can show you how to play it. It's rather complicated. This is the original edition of the game. It comes in a box like this. I understand there's another edition, but it's still the same game. And this is the name of the man who created it, Nguyen Khai Hai. Sorry, I don't pronounce that well yet either. But I have been studying this game, and I can show you how it's played. There are a lot of rules of this game, and we'll get to them, but the rules of the piece are a good place to start. This is the commander. This is essentially the king piece. It moves like a rook along the lines of the board. in these directions. It can or so it can move forward, backward, or sideways too, or diagonally one. Just as with the artillery, it's not allowed to cross just anywhere on the river. It can cross in the special crossing zones, or it can take a ride with the engineer, or it can shoot something across the river and therefore take its place across the river because it has made a strike specifically. The Air Force is very powerful. There are two of them. It actually moves 4 in any of the 8 directions. It's a very wide range. Now it's considered to be flying, so it can go over anything that would be in its way. The airplane also has a special ability. It can strike something at all. It only creates a safety area for the commander to go to. The commander can, well, not from here, but the commander from here, for instance, could go onto the headquarters, and there it would be partially protected. Anything except the artillery, the Air Force, or the Navy, which has artillery on it. So if an infantry, say, were threatening it, this is what would happen. The infantry could not attack it, but it could first attack to break the bunker, and then it would be attacking this. But for instance, if an aircraft were threatening it on the bunker, it's just in check and has to move. The bunker doesn't matter to the aircraft, to the Navy, or to the artillery. Yeah, he's got to get out of there, and he can go far. So if he went that far, he'd be safe. Let's talk about pieces being carried by other pieces. Pieces that carry others are basically the tanks, the Air Force, of course, the Navy, and the engineers. Pieces that ride on others are, well, first of all, the tank or the Air Force can ride on the Navy, okay? It can be a carrier for tanks or an aircraft carrier. How does that happen? Well, the tank would go to the Navy vessel. As a move, it would go onto it. The airplane, similarly, could fly to the vessel, and as a move, it would mount that. The Navy can be loaded with a tank, aircraft vessel, and another rider. It would be unusual, but it could even have the commander on top of all those, and it would move like the ship. Everything is on the ship. So it would move like that until the other pieces depart from it. Let's talk about the engineer for a moment. There are certain pieces of machinery which are too heavy to cross the river. They can cross on these special crossing zones, but they can't cross in other places. Can take a ride on the engineer, the idea being that the engineer is actually a bridge building unit. Let's see, those are the artillery, the anti-aircraft gun, and the missile. Any of these can mount on there, and then the engineer can make a move to come over the river. So who can ride on a tank? Commander could ride on a tank. Infantry can ride on the tank. Militia can ride on the tank. Who can ride on an airplane? Infantry, commander, militia. There's very clear logic to this. These are, personnel. They can ride on an airplane. Who can ride on the Navy? Personnel, aircraft, tanks. And this is sensible too. This craft can carry even these heavy vehicles and these individuals. The ship is allowed to move freely in the sea up to 4 points. It can move diagonally. It can include going to the river, and of course, these points along the bank are considered within its range. It can go into the river, but it can't go as far as this reef or any further. Clearly, this is a shallow water area. It can shoot up to 3 points on the land. So when it comes along land, it's a very powerful attacking piece. However, it can get stuck in the river because escape channels are rather narrow. Here's an important point about the Navy. This is considered to be several pieces at once. It's the ship itself, it's the anti-aircraft gun, it's the artillery guns. So it's actually allowed in one move to shoot more than one of those guns. For instance, if it shoots the Navy here, it can also at the same time be shooting its artillery gun in this direction. So in one turn, it can shoot this artillery and shoot this naval vessel.
It's very nice.
There's another instance where one side can move essentially more than one move at a time. That's when pieces are stacked up and riding on each other. Here's an example. Suppose this Navy piece had an Air Force on it and also a commander. As they get off of the Navy vessel or strike from the Navy vessel, they can do this all at once. So the commander could go forward to some safe spot. The Air Force could fly off to another area, and the Navy might say, come down here. One of those pieces might be attacking another, not the commander in this case, but if there were a piece here, the Air Force could be attacking it. Those things happen all in one move, which is unusual. I recommend that you go through some of the sample games when you see some of these plays in action. It takes a little getting used to because they're a bit different from chess. Let's just mention pieces going past or over each other. As you know, the Air Force can fly over another piece. It's not obstructed by anything because it's an airplane, so it's flying over something. The artillery can shoot over a piece. So for instance, if this artillery were here and it had a target over there, it could shoot that, boom, land on it, take it off the board. So that's another thing that goes over something. And of course, there are no obstructions to the air zone. This piece is here, say it had another piece here or something, and an aircraft tried to fly through its air protective zone, say like this. It would be shot down at that point, taken off the board. Let's talk about how pieces get status of a heroic piece and what that means. Any piece that puts the commander in check, threatens to capture the commander, the guy with the star, becomes a heroic piece. And once it becomes a heroic piece, it gets extra power. So, for instance, if this guy actually, with his limited move, comes up to the commander and puts him in check, commander runs away, this piece becomes a heroic piece. So where his original move was one space in each direction, his new move is going to be 2 spaces in each of these directions. And here's something more. Because he was limited to only going on the lines in the orthogonal directions, being a heroic piece also entitles him to going in the diagonal directions. So look what he benefits in power from being a heroic piece. There's the heroic infantryman. Now, same thing for these other pieces that originally move only one space orthogonally. For instance, the engineer becomes a heroic piece. The anti-aircraft gun, when it becomes a heroic piece. Now notice that these pieces not only have the power to move the extra spot, but they also have the power to attack the extra spot too. So even, for instance, if this guy were attacking a gunboat out at sea, he would still have that heroic power to attack one step more than he could attack before. The militia originally moves one step in any direction, including diagonally, like this. Now, if it becomes a heroic piece, it can move to the additional points on the perimeter of that. The missile originally can attack these spaces as a heroic piece. It can go one step further, like this, and attack an additional point, 2 diagonally or 3 orthogonally. Often an Air Force jet will become a heroic piece, and that's very significant. I won't show you all the directions, but you know it can go any of the 8 directions. So instead of just going 4, it can go 5 along any direction. In addition, the Air Force jet becomes a stealth jet. When it becomes a heroic piece, it can go into enemy firing zones without being shot down. So for instance, previously, this jet would not dare go into the range of that anti-aircraft gun, but now it can go freely to it and even past it with its move of 5 in a line. And as I mentioned, that 5 extends in all 8 directions. I'm only showing you one, for example. That's after it puts the commander in check, which often happens because the Air Force is a very aggressive piece. Let's look at the naval unit. As you know, it can travel 4 spots along the sea or shoot 4 spots along the sea. If it becomes a heroic piece after checking the commander on the other side, it will have 1 more range in both shooting and moving. Same thing on land. You may remember that the naval vessel can shoot 3 onto land because it has an artillery on board. If it becomes a heroic piece, it shoots 1 further on land. And I'm not going to do each direction, but these guys do move and shoot in all 8 directions, including diagonally. The tank, did I mention it can go 2 steps orthogonally, right? Becoming a heroic piece, it would be 3 steps orthogonally, but since heroic pieces always are allowed to move diagonally, it would also get 3 steps diagonally, and this would go for all directions, all 8 directions as a heroic piece. By the way, if the commander has just 1 defender left, even though that defender has not checked the opposing commander, it becomes a heroic piece just by virtue of its important status in trying to defend that commander. Let's talk about the object of the game, because that's a little different from chess too. There are a few different ways of defeating the opposing team, and this is significantly different from the main forms of chess. Yes, if you force capture of the opposing commander, that is winning. That is checkmating, like checkmating the king, or as in Chinese chess, it's like checkmating the opposing general, same idea. But that's only the command attack. You can also win by destroying all of the sea-going vessels or all of the air force or the relevant land forces, which includes the infantry, artillery, and tanks. Keep that in mind, infantry, artillery, and tanks. So if you lose both of your Air Force flyers, you have lost the game. The last one is considered to be checkmated when it is forced to be captured, and that is a loss. If you lose both of your naval vessels, lose one, okay. Second one gets trapped. It's going to be captured no matter what. It is considered to be checkmated, and you lose that way. Same thing if you lose 2 infantry plus 2 tanks plus 2 artillery. Now that's a lot to lose, but the last one you lose gets checkmated, forced to capture, and that loses the game as well. That's how the game loses by checkmate. Now, sometimes the game is played with a time clock, usually 10 or 15 minutes. It's pretty quick. And then often checkmate hasn't occurred. In that case, there's a point count. The pieces that are captured are counted up. A few extra points are counted for other things. And then whoever has the best point score wins. I'll just run this by you real quickly. I'm going to say it, but you really want to have this list on hand if you're going to be using point score, because it's not so easy to get verbally and visually. So I'm going to say this from the lowest to the highest. These pieces are all worth 10 points. The infantry, the militia, the engineer, the anti-aircraft gun, and the headquarters. Okay, worth 20 points are the tank or the missiles. Worth 30 points is the artillery. Worth 40 points is the Air Force. And you can kind of remember this because the ones that have a wider range pretty regularly get 10 more points in value. So as I was saying, the Air Force piece is worth 40 points. Now the Navy is an interesting piece because it's added up. It's got the anti-aircraft gun, it's got the artillery, it's got the naval vessel itself with its torpedoes. Anyway, it totals up to a value of 80 points. So there's the point system, which you'll probably want to look at on a piece of paper and sit down with a pencil and make lists and figure that out if you come to that. But generally, you're probably going to be going for the checkmates because that's the more familiar approach to the game. And those fast games are usually used in tournaments where everything's timed. You have to have a winner. They go by the point system. Well, and by the way, if you checkmate the commander and you have the highest point score, then you get 200 bonus points because you actually got the opposing commander without making huge sacrifices. Let's go on to something you definitely want to know, how to set the pieces up. Now to do that, you notice I've been using this large board, which doesn't really fit easily into my screen here. So I'm going to change this to the smaller board that fits my camera just right. See? Same board, but smaller, still fits the pieces, but it's compact enough so that it fits in the screen and the pieces don't get too far away. You can still make them out pretty much. Now, let me show you real quick how the pieces are set up. It's clearly shown in the book or any instruction manual that you'll be getting for this. You can see that it's very symmetrical. If you take the Navy away, everything is entirely symmetrical, and I'm going to name them quickly. Commander, headquarters, Air Force, missile, artillery, tanks, anti-aircraft guns, militia, engineers, infantry. Exactly the same on the blue side, mirroring this side. Now, as I mentioned, the Navy, these guys are not symmetrical the same way. They're symmetrical with each other, but they break the symmetry right and left of the land forces and air forces. These guys are the Navy. They start in this position. That's one setup. The other setup is like this. You take a screen of some kind, keep it between the two sides. You set up your forces however you want. The opponent sets up their forces also in secret. And then before the game begins, boom, the secret is revealed, and you just start fighting wherever you are, however you did. Now that's considered the more advanced. The basic setup is like this, and it's recommended that you get familiar.
Đây đây. Nếu mà dẫn con đỏ mà lên thì đây là đầu có dây, đây đầu có xanh. Nhưng mà đứng chỗ này là an toàn. Và đứng chỗ này không an toàn mà còn có thể ăn được.
Yes. Oh. Games. Chess.
Well, matter can be changed. I might be able to take this and shred it up and make it into something else. And that would be changing this cloth. You know what we can change this into? Let's say I want to make it paper. That's possible. This can change. The food you eat. Well, let's say you eat an apple. It changes once it's inside of you, doesn't it? Let's say you eat a banana. Once you chew on that and swallow that, it changes. Matter can change. But what is matter? Well, all the stuff that make up who you are or make up
Shut. Chat.
This rag, or make up that apple or that banana that you ate, that's matter. All the stuff inside of it makes up the matter of that object. And that matter can change. When we pick an apple off an apple tree, or we get an apple from the supermarket, it looks one way. Maybe it's a red apple, right? Big, shiny, red, delicious apple. Take a great big bite. Chew it up. Take another bite. Chew that up. And of course, we swallow. Take another. Another bite, chew that up. Well, at the end, the apple no longer looks like it did at the beginning. It changed. So what made up that apple still exists, but it looks different now. It went inside of us to help us get what we need to keep living. So that banana, that apple, even this cloth, made up of all this stuff, can change. It can go from cloth to paper. It can go from apple tree to food. It can go from banana tree to food, because matter, all matter, can change. and you matter. So you can change too. See you next time.
Buổi chiều thì không ngủ à? Đi ngủ đi. Ngủ với ba hay ngủ với ai? Đi ngủ với ba hay ngủ với ai?
Con vô một mình đợi đến khi mẹ về.
Mẹ đâu về được đâu.
Mẹ có về chưa?
Tối nay mẹ không về.
Có về.
Mẹ nhận được đau không về.
Ba nói láo đó.
Bây giờ tắt đi. Tao lại tắt.
Ba
Mắt bị lẻ rồi. Vậy muốn đeo kính không? Muốn đeo kính không? Ừ? Ngủ đi con. Nghe lời ba nghe. Chứ ba nói với con này. Nó ba xuống dọn nhà này nhưng mà phải lên nhà phải gặp con để ba ôm con ba khỏi chuyện này.